Hi, my name is Phil. Welcome to my YouTube channel, Mazatrol Tips and Tricks. In this video, I'm going to show you how to machine this part I got right here. This is going to be our third demo piece, and it has turning, drilling, and milling in it. So let's get started programming this part. All right, here's our third part, what it looks like. So the first thing we're going to do is go to the program screen, the left button, go to program, program file, and we're going to select a work number that is not listed up here. So 23 is not up here, so we're going to choose that work number. So go back to program, push work number, type in 2-3 input, and it says program number was not found. If it's a new program, push this button. So push program. Now it's asking us Mazatrol or EIA, and we're going with Mazatrol on this. Workpiece material, we're going to choose aluminum. Maximum outside diameter of workpiece is 3.25 inches. Minimum diameter of workpiece is 0. It does not have a hole in it. Workpiece length is 3 inches long. Max spindle RPM limit is the G50 for the entire program, and I don't want to run the chuck past 2,000 RPM, so type in 2,000. Finish allowance on X. This is the stock that the roughers are going to leave for the finishers to clean up. I'm going to leave 10 thousandths on the diameter, so type in 0.01. Finish allowance on Z is 5 thousandths. And the stock removal of the work face. This is how much we're facing off the end of the part. In this case, 100 thousandths. Input. Now the first process we're going to do is turn on the coolant. For that, we need to push these 3 arrows, go over here to M code, and then coolant on, and then down arrow. So now the next thing we're going to do is face off the excess stock on our part. So we're going to push edge, and then again, the surface speed for rough cut, finish cut, and depth of cut we can set automatically by pushing this button. The roughing tool number, we're going to use tool 4, which is our CNMG. Offset 1. Finish tool is tool 4, offset 1. Starting point on X is going to be our stock size of 3.25 input. Starting point on Z is going to be the 100 thousandths, 0.1. Final point on X and final point on Z are both 0. Surface roughness, we're going to choose number 7. What I didn't explain before is the lower numbers are a much coarser feed rate, and the higher numbers are a finer feed rate. 5, 6, and 7 are in the middle. A 7 is close to a 32 finish, a little finer than a 32. So I usually choose that. So down arrow. So we face the edge of the part off. So now what we need to do is describe this OD line right here that starts at 2 inches and it has 100 thousandths chamfer at the front of it. So we're machining bar stock. We're on the open geometry on the outside. Cutting point on X is 3.25. Cutting point on Z is 0. Surface speed for rough cut, again the auto comes up. Push that. If you wish to override it, you can do that. Roughing tool number, we're going to stay with tool 4, offset 1. Finish it with tool 4, offset 1. So now what we need to do is describe the shape. This is going to be linear. Starting corner is going to be the 100 thousandths, 0.1. Final point on X is going to be 2 inches. And the final point on Z is going to be 700 thousandths with 100 thousandths corner at the end of the line. So we push this radius button here first. That changes whatever value I type in into a radius. And you can see the yellow R pop up. Surface roughness is 7. down arrow. Now let's take a look at our shape. So right button, figure check. And we've got the 100 thousandths coming off the face. And then we've got the diameter turned up to the stock size. If we push the store button, we can see what changes we have from now until we're done programming. So push store, go back to program. And now we need to make this horizontal line. Vertical lines, as you saw in this trace, are done automatically. So we need to focus on the horizontal line, and it has a 2.5 inch diameter with 100 thousandths radius at the front of it. So push linear, push radius, 0.1 input, final point on X is 2.5 input, and the final point on Z is going to be 1.75 inches with a 200 thousandths radius at the end of the line. So radius, 0.2 input, surface roughness is 7, down arrow, right button, figure check. So this kept the image from before, and we can see that we added another linear line to the program. We're not done with it yet, so let's go back to program. We need to make one more linear line, and that's in order to chamfer this part right here. So go linear, starting corner is 100 thousandths. Final point on X is going to be our stock diameter of 3.25. Final point on Z is going to be 1.75 plus the 100 thousandths chamfer plus 2 thousandths to roll the insert over the top of the radius. If we don't do that, it leaves a little tiny burr there. So 1.852 is our finish length. Surface roughness is 7, down arrow, shape end, right button, figure check. Now we can see the two chamfers on it, but let's blow this up a little bit to get more detail. So push the scale button, move the cursors up and over, and that white box will be the center of the screen when we change the scale. So let's give it a larger scale of like 1, enter, and that blew it up a little bit. So let's go back to program. So now what we need to do is we need to punch this hole in the center of the part. So this is the first menu that comes up, but there's not a drill on the first menu. So we push the 3 arrows. Here's the drill. Push that. And the drilling type has 4 different selections. 0 drilling feeds in and feeds out at the same feed rate, and it's useless on this machine. Number 1 pecking feeds in and then rapids out to the start. Rapids back in, feeds a little more, rapids back out as a chip clear. Number 2 pecking feeds in, rapids out a little bit, and breaks the chip. And number 3 reamer feeds in and then feeds out at double the feed rate. Most of the time we're going to select number 1 pecking. Drill diameter, in this case, it's 0.69. Depth of first cut, again, we got an auto that comes up. So if we push that, it'll auto-populate our depth of cut, our feeds and speeds. So the first field is the depth of first cut. This is how much it's going to take when it first enters the workpiece. The second one is the decremental depth of cut. This is how much it's going to minus off of the depth of cut on each subsequent pass. And then finally, the minimum depth of cut for deep holes. When this goes down, the minimum depth of cut is going to be 3 millimeters or 118 thousandths. Surface speed and the feed rate. The tool we're using is tool 13, offset 1, Starting point on Z is going to be the front of the part. The final point on Z is going to be the hole depth of 1.57, and that goes to the end of the hole. On this older machine, it does not compensate for the drill point angle. The newer machines will go down to the major diameter of the drill, past the drill point. On this one, it does not. So type in 1.57 input, down arrow, and then right button, figure check. And now we've got a hole punched in the part. Again, you can see there is no angle shown on the hole. Go back to program. So now what we need to do is describe this bore size. The bore, it's a 900 thousandths bore with a 100 thousandths chamfer at the front of it. So again, we're using bar stock in this time, and it's still open geometry. Cutting point on X is going to be our drill diameter, 0.69. Cutting point on Z is 0. Again, surface speed for roughing, we push auto and it auto-populates our feeds and speeds for us. Roughing tool number is tool 12, offset 1. Finish tool is tool 12, offset 1. So the next thing we're going to do is the linear. Starting corner is 100 thousandths. Final point on X is 900. The final point on Z is going to be 1.3 inches. And the final corner, I forgot to put on the print, is a 50 thousandths radius at the bottom of the hole. So push radius 0.05 input. Surface roughness is 7. Down arrow. And now let's chamfer the hole going into the drill. So go linear. Let's give it a 20 thousandths chamfer. 0.69 for the hole size. And then we got to go this dimension, 1.3 plus 20 thousandths plus 2 thousandths to roll that insert over the chamfer. So 1.322 input. 7, down arrow, shape end, and then end. I haven't touched on the end process in the machine yet, but this is very powerful when you need to do multiple parts or switch between programs and etc. It's very useful for bar pulling. On this process, we just need to push end and leave everything 0. So let's go to the right button, figure check, and there's our bore. So now let's look at the toolpath. So left button, go to program, that gets us out of edit mode, push check, and then check continue. So what it's going to do is it's going to rough the face, then it's going to finish the face, and it's going to rough the OD, toolpath erase to erase what the graphics. Here's the finish OD pass. Now it's going to drill the hole in the center. Now it's going to rough the bore. Toolpath erase. And now it's finishing the bore. So this is how it's programmed, but this is really not how I want to run this part. I would like to rough out the part and then run the finish tools. So I'll show you how to do that now. So go to layout, and if you notice, it's got R1, which is the coolant, R2 is the edge process, this is the roughing process, and then the finish process, and so on down the line. Now if we push rough priority on this screen and then push the input button, notice how it reorganizes all roughing processes up front and then finish processes at the end. And this is fine for how it's programmed, but to eliminate one tool change, I want to move this finish bar in process above the finished turning process. So to do that, move your arrows down, and it's going to insert a line above where the cursor is. So go move, process to insert. It's going to be a finish process, number 5, input. And now if you look, we're roughing it with tool 4, drilling it with 13, roughing it with tool 12, finishing it with tool 12, and then come back with the tool 4 to finish the face and finish the OD. You got to be careful on this screen because you can actually put the finish tools above the roughing tools and crash the part. So when you play with the layout, you got to be wary of that issue. The newer machines have a protection against that. On this one, because you're doing it manually, it'll allow you to do that. So let's go back to the program, check, toolpath erase, and then check continue. Now it's roughing the outside. Now it's changing tools to drill it. Rough the bore. Toolpath erase. Finish the bore. Finish the face. And now finish the OD of the profile, and it's done. So now from here, what we need to do is set the work shift. So we're going to come over and set the Z0 for this program. All right, we're ready to set the work shift. So come up here to manual. Come over to the face of the part. And let's turn the spindle on, like 300 RPM. There we go. All right, we're touching the face and we easily cut off 100 thousandths. So stop the spindle. Come over here and go to program. Go to program file. Arrow down. Arrow over to the Z offset. We're going to teach it. So push Z offset teach. 0.1, we're 100 thousandths in front of our 0 because this is the rough stock we're machining off. Hit input, and now we've taught Z. So now let's go to the position screen, and we're in program number 1 right now. So that's why the Z is not at 100 thousandths. So push auto, push work number, 23, input, and now we're at 100 thousandths. We, on the run side, we're on program 23. So let's go to the trace screen. So left button, trace, and now we can see our turning tool just like it is on the part. So now what we need to do is go to auto, turn on the coolant in auto, not in manual. And then let's hit cycle start and run this part. Making its 2 roughing passes. right. Now comes the drill. And we're done drilling the part. Bring up the boring bar. All right, done roughing it. Now it's the finished pass of the boring bar. Now it's going to come up with tool 4. So right now it's cutting a little bit of air before it cuts the part. In later videos I'll show you a trick to get rid of that. But for this video, it's fine. And we are done. 2 minutes and 56 seconds. All right, now in this case, I want to show you guys how to rerun a process in order to dial in the part. So let's say the OD was 2 thousandths bigger than it should have been. First thing we're going to do is going to go to the wear screen. So we're going to push the left button, go tool set, and then we're going to arrow down to wear offset number 1 in X, and we're going to go minus 0.002 input. So this is going to take 2 thousandths off on the diameter on tool 4. So now what we need to do is go back and let's go to the program, to the layout screen, and we want to run the last process, the F3, the finish 3 process. So what we're going to do is going to push this button down here, single process, go to position, and it's asking us which process do you want to run. We're going to push finish 3 input, and then we can do the same thing on the trace screen. So finish 3 input, there's the coolant. Now let's close the door and let's hit cycle start. And one thing to note, it says 2.498 on that diameter. On this machine, and on every Mazak that I've come across, the wear shows up in the geometry when you're running the part. Some people found that annoying, but it's a nature of the Mazak. You can actually see there's a wear going on because it does adjust the geometry. All right, and we are done. And if we check it, check the size, if we like it, or we can rerun it again. But that's how to rerun a finished pass using Mazatrol. So we are done with the part. blow it off. And that's our finished part.
Good.
If you like this video, please give it a thumbs up and subscribe. Also push the bell notification to be notified when we get new videos coming out. Thanks and keep watching.